Alpha beta pruning, it is the modified version of Minimax algorithm. It is an optimization technique for the Minimax algorithm. The Minimax search algorithm generates number of branches and that are exponential. Uh, since we cannot eliminate the exponent, but we can cut it to half. Hence, there is a technique by which, without checking each node of the game tree, we can compute the correct minimax decision, and this technique is called pruning. Now consider this example. In this figure, we have two players. One is Max and the other player is Min. Max and min we can represent alternatively on alternative levels. For example, the top node belongs to max, and then the nodes on the next level belongs to min, and again the nodes and the next level belongs to max, and the nodes at the bottom we call it static nodes, and this is called static nodes because the values of these nodes cannot be changed. We can alternatively use alpha for max, and we can use beta for min. The max will try to get the maximum number on the board, while min will try to get the minimum number on the board. So the worst case for max will be equal to minus infinity, and the worst case for min will be positive infinity. Again, why this will be the worst case for max? Because max is trying to get the maximum number on the board, so the worst case will be minus infinity, and vice versa. Now we will I will show the values, for example the values of alpha and the value of beta at each node. So at the top node, the alpha will have minus infinity, and beta will have positive infinity. At this node, again alpha will have negative infinity, and beta will have positive infinity. And at this node, alpha will again have negative infinity, and beta will have positive infinity. So this node belongs to max. So now max will try to maximize the value which it has. So by default the max has a value minus infinity. Now it will search for these nodes, so it will search for this node. So it is the value at this node is equal to 4, and max will compare this value 4 with the with the value which max has already, and max has minus infinity. So plus 4 is greater than minus infinity, so max will adopt here plus 4, and Again, max will search the next node, and here the value is 3, so it will compare 3 with 4. So 3 is less than 4, so max will adopt this value 4. Now the value of max become 4, and the value at the node value is also equal to 4. This value will come to this node. Now I will erase these circles. So here this node, the value of max is equal to 4. It has been changed from negative infinity to 4, and the value of node is equal to 4. Now at the top of this node we have min, so min have to look for this node, so it is equal to 4. Now min will compare the value of this node with the value which it has already, so it has positive infinity, so 4 is greater than positive infinity, so the min here will adopt a value equal to 4. So this node, the value of this node is equal to 4, and the value of min beta of min is equal to 4. Now here min will look at this node, and this node belongs to max, so max will search for these two nodes, and here we will figure out that what is the value of beta. The value of beta is equal to 4, and the value of alpha here is equal to minus alpha, the worst case. So this is the turn of max, so max will get 6, and it will compare with the negative infinity, so 6 is greater than negative infinity, so the value at this node will now be 6. Now here is an important point. Here we will prune this node, and we don't need to search this node, and if there are any subtrees, all of them we will not search all those branches. Now here we have to understand the point that why this node has been pruned. So first of all I will erase all these circles. Now here uh, the at this node we have got 6, so here the value of beta was equal to 4, and the value of alpha we have got equal to 6. Whenever the value of alpha becomes greater than value of alpha becomes greater or equal to the value of beta, then the other nodes will be pruned off. So there is no need uh, no need to search these nodes, because at the top this level is of max, and at the top is min, so whenever the max at this node get greater value than uh, uh, then alpha. So it will prune off these values. For example, let's suppose, for example, if we here we have value 7, and the max select value 7, the min will return value 4, and if there is a value less than 7 or 6 or less than 4, so the min will not select that value, but sorry, max will not select that value, but it will select values, the max value. And at uh, this point, the min, the value of min will not be affected whenever at this point max get value equal to or greater than beta. Hope you will have understand it. So I will erase the circles in the. Now again, uh, this node belongs to alpha or max, so it will compare the value. Here the value is minus infinity, which is and here the value is 4, so that value will equal to 4. Now the max will now try to take a value. It will try to take a value which will be greater, which is greater than 4. Here at this level, that is min. So min will check the this node, and this node at that level belongs to max. So here the value at this point max is okay. Let me erase uh, these writing. Now look at this point here. Here this level belongs to max, and it will search the value here equal to 2, and and it will be equal to 2. So alpha here is equal to 2, and then it will search this node. So as the value of this node is greater than the value of this node, so max will adopt this value. Now at the top level is value beta, or it is a min. So now here the value of alpha or max is equal to 2. Now this is min. Here the value for the value for beta will be positive infinity, and the value for alpha will be 4, and because these values have come from the top node, so here the beta will compare its value. So beta value of beta is 2 is greater than positive infinity. so the value of beta will become 2. Now at this point we prune this branch and also we prune this branch because the value of alpha is greater than the value of beta. For example, uh, if we search these two nodes, so this is max and then it will get 9, and if we search these two nodes, so this level belongs to max, so it will take 3 again. At any case, the beta will take this value too, so we don't need to uh, search these nodes. And if for example these nodes have uh, more subtrees, so all these nodes will not be searched, so hence it will reduce these the solution space or the problem space. Now here I will again remove the circles and text. Now the search will backtrack, and here the value is equal to 4 at this node. The value of max is equal to 4. Now this will pass down the value. Here the value of uh, uh, alpha will be equal to 4, and value of beta is infinity. So here this node will be searched. So this level belong to max, so max will search this node and it will take 5, value 5. Again it will search this node and it is less than that, and 5. Now we have value beta, so here no so that is equal to 5. Here beta is positive infinity, so it will take 5. Now again it will search for this it will search for this node, and it will search for this node. So this level belongs to max, so max will select this node which is equal to 7, and it will take this node equal to 7, and this node is equal to 5, this node is equal to 7. So this node will be pruned because at the top we have min. So whenever at this point the alpha value is greater than already here a value, so it will be pruned off, because the min at this point will always look for the minimum value, and here the max will look for the maximum value. So max has got the value greater than this here alpha, so there is no need to search this node. So here it will get 5, and now the alpha value at top will be equal to 5. So here this value was 4, here this value now become, the greater value become 5. So the alpha or the max will adopt this value 5. So at the top node, the value of alpha will be equal to 5.